All right, let's jump into it, shall we? Today, we're looking at Microsoft's Trace.
Trace?
Yeah, and we've got their GitHub page and some academic papers to dig through.
Sounds fun.
Yeah, it should be fascinating. Trace, it's being called. Like the auto-diff for AI agents.
Yeah.
I remember auto-diff back in the day from deep learning. You know, it kind of revolutionized how we trained those neural networks.
Yeah.
But how does that relate to AI agents, though?
Well, it's about automation. So, AutoDiff automated all that complex math behind deep learning.
Okay.
Trace is kind of aiming to do the same thing for building and optimizing those AI systems. All those complex ones we see more and more these days.
So it's like, taking all these intricate workflows, the different models, the data sources, and like making them all work together smoothly.
Yeah, exactly. Think of like a giant orchestra.
Okay.
All those instruments, all the components need to be tuned perfectly for it to sound good. And manually tweaking those parameters, that's...
Yeah, a nightmare.
Yeah, it is a nightmare.
That sounds like a conductor's worst nightmare, for sure. So Trace just steps in and kind of takes over that task.
Well, yeah, it kind of introduces a paradigm shift by automating that optimization process.
Okay.
It observes your AI in action and creates like a map, like a directed acyclic graph, a DAG.
A DAG, huh? Is that like one of those flowcharts I used to make in computer science class?
Kinda, yeah, similar. Think of it as like a visual representation of your whole AI workflow.
Okay.
So it shows each component, how they connect, how the data flows through the system.
Gotcha. So Trace is using this DAG to understand how the pieces all fit together.
Yeah, and more importantly, it figures out how tweaking each component affects the overall performance. So it's like an AI assistant, right?
Yeah.
It's looking at your AI, figuring out the bottlenecks,
Wow.
and suggesting improvements to make it run better.
That's slick. The research also talks about mappers, though. What are those?
Yeah.
And where do they fit into all of this?
Mappers are essential for any task where you're splitting up work among lots of processors.
Okay.
Like when you're doing some heavy data crunching, they're like instructions telling each processor what part of the data it should work on.
So it's all about efficiency, making sure all the processors are doing their job.
Right. Yeah, but traditionally writing these mappers involves a lot of low-level coding.
Oh, I bet.
In C++ often.
Yeah.
Which is tedious and specialized and pretty error-prone.
So many lines of code. It's like, composing a symphony. But you have to arrange every single note yourself.
Yeah.
There's got to be a better way.
Well, there is. That's where Trace comes in.
Right.
Instead of battling with C++, it introduces a special language, a domain-specific language, or DSL, that's way easier to read.
So you're saying it translates all that complicated stuff into something more manageable.
Exactly. And this DSL isn't just easier for us humans, it's also perfect for another AI player in all this, OptoPrime.
Wait, hold on. Another AI. Who's OptoPrime and what does it do?
OptoPrime is like the brains behind Trace's optimization magic. It's an algorithm that's powered by, you guessed it, large language models.
LLMs.
Yep.
So we've got one AI optimizing another AI.
Right.
It's AIception. How does that even work?
It's pretty ingenious, actually. So Trace takes that DAG, the map of your AI workflow, and bundles it with the DSL code and any performance data, and basically presents that all to OptoPrime.
Okay.
Like it's a detailed report.
So OptoPrime has like a bird's eye view of the whole system and how well it's running.
Yeah.
But LLMs, those are usually trained on text, right?
Yeah.
How can it understand code and performance data?
Well, that's the cool part. Think of the DSL code and the performance data as a specialized language, right?
Okay.
It's like Trace is translating for OptoPrime, giving it a cheat sheet to understand this technical domain.
Oh, I see. So it's like giving OptoPrime the instructions and the data.
Yeah.
And then it can use its language skills to figure out how to best tweak the code.
Exactly. It can look for bottlenecks, identify issues, and suggest solutions, kind of like a human expert would.
That's wild. What if there's like a bug in the code, though? Can OptoPrime handle that, or does it need everything to be perfect?
Well, one of the best things about Trace and OptoPrime is how they handle feedback.
Okay.
And that includes errors. So imagine you're compiling code and get a bunch of errors.
Ugh. Yeah, I've been there. It's frustrating, all those cryptic messages.
Well, Trace takes those errors, incorporates them into the feedback loop,
Okay.
and uses them to refine the optimization.
So it's like having like a tireless assistant who never gets tired of debugging.
Yeah, that's a good way to put it.
So it's not just a one-time thing. It's continually learning and refining based on the feedback, even those errors.
Exactly. And the feedback isn't limited to just errors either. It can even take suggestions from human experts, which makes the whole process more robust.
So it's really like a collaboration between AI and humans, both working together to optimize these systems.
Exactly. And this leads to some interesting results. When they tested Trace on different applications, they found it could make things significantly faster compared to handwritten code.
Okay, so how much faster are we talking about? And what kind of applications were they testing?
Well, with scientific applications, Trace was up to 3 times faster than manually written mappers.
3 times faster. That's huge. So this could be a real game changer for scientists dealing with these massive simulations.
Yeah, definitely. And it wasn't just scientific stuff. They also tested it on a bunch of different tasks, like optimizing matrix multiplication algorithms and even higher-level AI tasks like reasoning and robot control.
Wait, so it's not just for low-level code. It can optimize whole AI workflows, even for complicated things like robotics.
Yeah, that's right. And that's one of the big takeaways here.
Okay.
Trace isn't just for some niche problem. It has the potential to change how we build and optimize all kinds of AI systems.
This is where it gets really interesting, right? We're talking about democratizing AI development.
Yeah.
Making it faster and easier to build these sophisticated systems for all kinds of things.
Exactly. And that brings us to another exciting part. Deep agent workflows.
Oh, deep agent workflows. Okay. That sounds intense. What are we talking about here?
Imagine a web of AI components all interconnected, working together towards a goal.
Okay.
These workflows could involve LLMs, machine learning models, external data, and even human feedback.
So it's like a symphony of AI where each instrument, each component is playing its part in this bigger piece.
Yeah, that's a great analogy. And Trace provides the foundation for optimizing these deep agent workflows in a way that's efficient and scalable.
That's powerful. But wouldn't all this automation, wouldn't it take control away from the developers?
It's a fair point, and the researchers acknowledge that developing these deep agent workflows raises some big questions about transparency, explainability, and control.
So it's not just about building powerful AI, but also making sure it's responsible AI.
Exactly. And that means carefully considering the role of human expertise in all of this. But that's a conversation for another time. For now, let's delve deeper into how Trace handles these deep agent workflows and why it's such a game changer.
Okay, sounds good.
And what makes Trace so revolutionary is how it handles this complexity that would, overwhelm even the most skilled human developers. Remember those deep agent workflows?
Yeah.
Imagine trying to optimize a system with hundreds, even thousands of interconnected components.
Yeah, my brain's already hurting thinking about that.
Yeah, exactly. It's just not possible for humans to manage every little detail, especially as these systems get more complex. That's where Trace shines. It gives us this framework for automatically optimizing these complex workflows so everything works together smoothly.
So Trace is like the conductor orchestrating this whole AI orchestra.
Precisely. And it's not just focused on the individual nodes. It's looking at the whole composition, making sure that in this case, the AI is as impactful and efficient as possible.
Makes you wonder what's possible, right?
Yeah.
When we have AI that can automatically learn and improve.
It's exciting. More responsive chatbots, personalized recommendations that actually work, AI tools that anyone can use.
It's like taking all that complex AI research and making it actually useful for everyone.
Right, exactly.
But, we've focused a lot on the good stuff, the benefits of Trace. But are there any limitations?
Of course. Every new technology has room for improvement. For example, right now, Trace can't handle things like recursive operations or workflows that need to be spread across multiple machines.
So there are still some things that are kind of beyond its capabilities.
For now, yeah.
Okay.
But the researchers are working on it, expanding its functionality. It's still pretty new.
Okay, that makes sense. It's like any tool, there are always going to be strengths and limitations.
Right.
Okay, well, before we go too far down the rabbit hole here, let's switch gears a bit.
Okay.
Talk about feedback.
Feedback. Right. It's essential for any learning system, and AI is no different. What's interesting about Trace is that it doesn't just look at basic metrics like how fast something runs. It can incorporate richer, more nuanced feedback.
So it's not just about measuring performance, but understanding why it's performing that way and what to change to make it better.
Yeah. Think of it like training for a marathon. You wouldn't just focus on your finishing time, right?
Right.
You'd look at your pace, your heart rate, how you felt at different points.
So you need to understand the why behind the performance, not just the what.
Exactly. So how does Trace do this? Well, one of its key features is that it can process and analyze natural language feedback from humans.
Oh, interesting.
Imagine working with a chatbot and it just can't seem to understand complex requests.
Oh, I've been there. It's so frustrating. Sometimes you just want to yell at your phone.
Well, with Trace, you wouldn't have to yell. You could just say, hey, this chatbot is struggling with complex requests.
Okay.
And Trace, with the help of Optoprime, would analyze that and recommend changes to the chatbot's design or training data.
So it's like you're having a conversation with Trace.
Yeah.
You give it feedback in plain English, and it figures out what to do.
Exactly. And this ability to handle all kinds of feedback, that's what makes Trace so innovative.
Yeah.
It means we can train AI not just with data and code, but with human interaction and guidance as well.
It's like AI and human experts working together.
Exactly. And this leads to great results. For instance, in one experiment, Trace was able to learn from feedback to make a chatbot much better at a specific task.
So it's not just optimizing code, it's optimizing the AI's behavior.
Yes, precisely. And that's what's so exciting about this. We can use LLMs and automated optimization to create AI that's not just more efficient, but more in line with our goals and values.
So we're moving towards a future where AI is less of a tool and more of a partner.
That's a great way to put it.
And this brings us to another interesting aspect. How Trace handles feedback from those human experts. It's not just about understanding the words, but the structure of that feedback.
Right.
Tell me more about that.
Imagine an expert is giving feedback on a chatbot.
Okay.
They might say something like, the chatbot is too verbose. It needs to be more concise.
Okay, that seems pretty straightforward. What's the structure there?
Well, there's a structure to it. It's not just random words. There's a subject, the chatbot, a verb is an adjective, verbose, and a suggestion needs to be more concise.
Ah, so it's like the grammar of the feedback.
Yeah, exactly. And Optoprime, that LLM-powered optimizer, it can actually use that grammatical structure to extract information and give better suggestions.
Oh, wow.
So in that example, Optoprime would see that verbose describes the responses, and concise is what we want.
So it's not just understanding the words, but the relationships between them, how they convey meaning?
Exactly.
Right.
And this ability to extract structural information, that's key to how Trace learns from human experts.
That's really impressive. But wouldn't you need a really, really advanced understanding of language to do that?
You do, and that's why the progress in LLMs is so important. As LLMs get better at understanding language, tools like Trace become even more powerful.
So it's like a symbiotic relationship, right? The better LLMs get, the better Trace gets.
Exactly. And it highlights one of the big takeaways from this research: the power of LLMs combined with automated optimization.
It's like we're blurring the lines between code, data, and language.
Couldn't have said it better myself.
Okay, so we've covered a lot, the technical details of Trace, those deep agent workflows.
Yeah, even touched on some philosophical stuff with that emergent behavior.
Right, but let's bring it back to our listener now. What does all this mean for someone who isn't, an AI expert or a developer?
It's a good question because it's easy to get lost in the technical weeds, but the real impact of all this is how it can actually make our lives better.
Absolutely. So how could Trace even indirectly change things for the average person?
Let's take those online recommendations, for example.
Yeah.
Those systems that suggest movies or music. Ever feel like Netflix just doesn't get you?
Oh, yeah. Sometimes I spend more time scrolling than watching.
Now, imagine Trace being used to, really fine-tune those recommendations.
Yeah.
It
Yeah.
could look at what you watch, the feedback you give, even your emotional responses.
Hold on, emotional responses. How would an AI even know that?
That's where things get really cool. Researchers are figuring out how to use data from sensors like facial recognition or biofeedback to see how we react to stuff.
So Trace could use that data to give recommendations that are way more personalized, even beyond what we tell it directly.
Exactly. It's about going deeper than just ratings or clicks to really understand what each person enjoys.
That's amazing. But it's not just for entertainment, right? What about other areas?
Think about healthcare. AI tools that can analyze medical images but also learn from doctors.
Yeah, that could be huge early detection, personalized treatments.
Right. Trace could bridge that gap between AI and human expertise.
This is really making me think about all the possibilities. But are there any, downsides or challenges we should consider?
Of course. Like with anything, there are limitations and risks. One thing is transparency. As AI gets more complex, it's harder to understand how it makes decisions.
Yeah, that's a good point, especially in areas like healthcare or finance. We need to know that these systems are fair.
Exactly. And that's why research into explainable AI is so important. We need to be able to see into the black box to make sure these systems are accountable.